Imagine a puzzle. But this isn't a normal puzzle. It has a billion invisible pieces. They are constantly moving, and the shape changes every time you look at it. This is the protein folding problem. If you solve it, you cure cancer. You stop aging. You essentially unlock the source code of physical life. For 50 years, the smartest scientists on Earth tried to solve this. They used X-rays, lasers, and supercomputers. And for 50 years, they failed. They estimated that to map every protein in the human body, it would take a standard computer longer than the age of the known universe. Then, in May 2024, a team at Google DeepMind pushed a button on a server in London. And the timeline collapsed. It didn't take a billion years. It took a few minutes. The solution wasn't found by a human. It was hallucinated by a machine. This is AlphaFold 3. The artificial intelligence that didn't just learn biology, it mastered it. And it is about to change everything. We aren't just guessing chemistry anymore. We are computing life. But this time, it's not just proteins. It's everything. Previous AIs could only see the bricks. AlphaFold 3 can see the entire house. DNA, RNA, ligands, the antibodies protecting your blood. It simulates how the drugs you take interact with your unique genetic code. It watches the molecular dance of life in real time. DeepMind calls it a resolution revolution. Scientists are calling it magic. But to understand the magic, we have to understand the curse. Because before 2024, biology was flying blind. We need to look at how broken the old world really was. Let's talk about the protein folding problem. Scientists refer to this as the ultimate origami from hell. Your body is a machine made of proteins. They are the gears, the motors, and the sensors that keep you alive right now. A protein starts as a long, simple string of amino acids. But to function, it must fold into a specific, precise 3D shape. If it folds correctly, you breathe. If it misfolds, you get Alzheimer's. You get cystic fibrosis. Structure is destiny. For decades, finding that shape was a nightmare. We used a method called X-ray crystallography. It was slow, painful, and expensive. It cost $100,000 and took a full year just to map one single protein. We have 200 million of them. At that pace, we would finish mapping human biology, roughly around the year 3 million AD. We didn't have that kind of time. The villain wasn't a lack of effort. It was complexity. The number of possible shapes a protein can take is astronomical. There are more possible configurations for a protein than there are atoms in the entire known universe. We needed a shortcut. Enter CRISPR, the Olympics of protein folding. A global competition held every 2 years to solve these impossible shapes. For 20 years, progress was flat. Scientists were getting 40% accuracy. It wasn't science, it was educated guesswork. Then, in 2018, a team of gamers and AI researchers from London walked in. Google DeepMind. They weren't biologists, they were the people who taught AI to play Go and StarCraft. They saw biology differently. They treated the body not as a messy science, but as a pure data problem, a pattern to be recognized. AlphaFold 1 appeared. It won the competition, but it wasn't perfect. It was just better than the humans. The team wasn't satisfied. They went back to the drawing board. They threw out the code and started over from scratch. November 2020. CRISPR 14, the moment the history of biology split in two. AlphaFold 2 didn't just win, it smashed the test. It achieved 90% accuracy. Atomic precision. It solved the unsolvable. The organizers of the competition were stunned. They declared, "The protein folding problem is officially solved." DeepMind released the database, 200 million structures, free for everyone. It was a gift to humanity, but it wasn't enough. Because life isn't just proteins floating in a void. Proteins are social creatures. They need to interact. They bind to DNA. They grab RNA. They react to other molecules. AlphaFold 2 was great at solo portraits. But biology is a crowded party. It couldn't paint the family photo. And for drug discovery, the interaction is the only thing that matters. A drug is a key looking for a lock. DeepMind realized they had built a museum of statues when they needed a simulator of life. So they went dark again. For 2 years, they worked on the large model of biology, a system that could predict everything. They spun off a new company called Isomorphic Labs, a company dedicated solely to finding digital drugs. May 2024, the silence breaks. A new paper drops in Nature. AlphaFold 3 is born. This wasn't just an upgrade. It was a new architecture. It was built on diffusion, the same technology that generates AI art, now generating the molecular structures of life. Instead of denoising pixels to make a picture, it denoises atom coordinates to make a molecule. The results were shocking. A 50% improvement in predicting how proteins bind to DNA, double the accuracy for drug interactions. In the world of science, this isn't progress, it's a quantum leap. They showed it predicting how antibodies fight viruses, how drugs bind to cancer. It was watching the war inside us. Suddenly, the guesswork of medicine started to look like engineering. Precise, calculable, solvable. But with this immense power came a controversial decision. DeepMind didn't release the full code. The scientific community was furious. They called it a black box. They said science must be open. But DeepMind argued that this tool was too powerful to just hand over. It could be used to design cures, or it could be used to design poisons, to build viruses that bypass our immune systems. The same key opens both doors. This is the dual-use dilemma. If you give the world a 3D printer for biology, someone will inevitably try to print a gun. DeepMind decided that safety outweighed openness. They restricted access to a server. You send the data, they run the model. It limits how fast science can move, but it prevents a bad actor from downloading the source code and going dark. Check me out. Head to Live Bahan. This decision sparked a massive debate. Is AI biology the property of a corporation or the heritage of humanity? While the ethicists argued, the engineers kept building, because the technology itself was getting smarter. AlphaFold 3 doesn't just memorize shapes, it hallucinates them. And to understand that, we need to look under the hood. Previous versions used evoformers. They looked at evolutionary history. If a protein changed here, it usually changed there to compensate. It was like solving a puzzle by looking at the picture on the box. Effective, but limited to what evolution has already done. AlphaFold 3 throws away the box. It uses diffusion. This is the same math that powers image generators like Midjourney. Imagine a clear picture of a molecule. Now, add static noise until it's just gray snow. That is the training process. The AI learns to reverse this. It looks at the static and asks, what molecule is hiding in this cloud? It starts with a cloud of random atoms. Step by step it nudges them. Move left, move right, get closer. It repeats this thousands of times, denoising the coordinates, until, out of the fog, a perfect structure emerges. This approach allows it to predict molecules it has never seen in nature. It isn't copying evolution, it's extrapolating physics. But there is a catch. Because it is imagining the structure, it can sometimes hallucinate. It can make things up. To fix this, DeepMind built in a confidence meter. The AI tells you, I am 90% sure about this part, but only 20% sure here. This is crucial for scientists. They don't waste millions of dollars testing a drug that the AI was just guessing about. So, we have a machine that can dream up new biology and tell us when it's dreaming. What do we do with it? We enter the era of rational drug design. This is the end of the throwing spaghetti at the wall era. Traditionally, finding a drug takes 10 years and $2 billion. It is a graveyard of failure. You find a molecule that kills the virus in a petri dish. Great, but then it kills the rat, or fails in the human. With AlphaFold 3, we can simulate the failure before we synthesize the chemical. We can fail digitally. We can cycle through 1 billion variations in a week. Evolution takes millions of years to do that. This is exactly what Isomeric Labs is doing right now. They aren't just publishing papers, they are partnering with Big Pharma. They signed deals worth $3 billion. The pharmaceutical giants aren't skeptical anymore. They are all in. Why? Because AlphaFold 3 unlocked the pocket. This is the secret to all medicine. Every disease-causing protein has a pocket. If you can jam a molecule in there, you turn a disease off. AlphaFold 3 is the best pocket finder in history. It finds pockets that humans didn't even know existed. It creates molecular glue, drugs that stick two proteins together to destroy a cancer cell. This was nearly impossible to design before. Now, it's just a prompt. We are moving from discovery to design. We don't find bridges, we build them. Now we build biology. But the most mind-blowing application isn't even medicine. It's agriculture. It's climate change. We can design enzymes that eat plastic, bacteria that suck carbon out of the air more efficiently. Evolution didn't have a reason to create a plastic-eating enzyme, but we do, and now we can build it. This is the moment biology becomes a programmable substrate, like silicon. Think about the central dogma of biology. FDA makes RNA, makes protein. AlphaFold 3 simulates the entire pipeline. It connects the code DNA to the machine protein. This means we can start editing the code and instantly see how the machine changes. Real-time debugging for life. Imagine GitHub for life. Scientists sharing patches for enzymes, forking the code of a bacteria. It sounds like science fiction, but the first drugs designed with these methods are entering human trials today. We are standing at the edge of the biology singularity, the point where progress becomes vertical. But every singularity casts a shadow, and the shadow of AlphaFold is knowledge. Knowledge is power, and power doesn't care who uses it. The cure and the weapon are just data. What happens when a college student can design a supervirus on their laptop in a Starbucks? The barrier to entry for bioengineering has collapsed. It used to cost millions. Now it costs a subscription. This is why the US government and the AI safety institutes are watching this tech closely. We solved the puzzle, but we might have unlocked a door we can't close. As we move into the final chapter, we have to ask, is humanity ready to play God? Because ready or not, the simulation is running. The fear isn't just about bad actors. It's about unintended consequences. Biology is chaotic. When we edit a gene or design a protein, we are pulling a thread in a tapestry we don't fully understand. AlphaFold predicts the shape, but it can't perfectly predict the ripple effect on the ecosystem. This is why wet lab testing will never go away. The AI is the compass, but the lab is the ship. However, the synthesizer gap is closing. Right now, ordering custom DNA is hard. In 5 years, it might be like ordering pizza. We need a digital bioshield, an AI that constantly scans wastewater and air for novel pathogens. If AlphaFold can design the virus, AlphaFold can also design the vaccine, in hours, not months. This is the arms race of the 21st century, not nuclear, biological, and the speed is determined by compute. But let's step back from the edge. Because for the patients waiting in hospitals, this isn't about war, it's about hope. It's about the undruggable. There are 7,000 rare diseases. 95% of them have no cure, because they weren't profitable to study. Developing a drug costs billions. Pharma companies couldn't justify it for a disease that affects only 500 people. AlphaFold 3 destroys that economic barrier. It makes drug discovery cheap enough for the long tail. We are entering the era of N=1 medicine, a drug designed just for you. Imagine scanning your genome, finding your specific mutation, and printing a protein to fix it. This is the mirror moment for humanity. We stop being the victim of our biology. We become the architects. We are taking the pen out of nature's hand and writing the next chapter ourselves. We aren't just fixing what is broken. We are asking, what is possible? Can we design proteins that stop aging, that repair UV damage instantly? that make us immune to radiation? Demis Hassabis, the CEO of DeepMind, believes this is the ultimate purpose of AI. Not to write poetry or generate memes, but to understand the universe. Biology is the most complex system we know, and we just built a machine that speaks its language. This is the digital biology revolution. It will be bigger than the Industrial Revolution. The Industrial Revolution extends our muscles. The AI revolution extends our minds. The bio-revolution extends our lives. So, where are we in 2035? 10 years from now? You might wake up, take a diagnostic pill, and get a custom supplement printed on your counter. Cancer might be managed like a chronic condition. Annoying, but not fatal. The age of blind biology is over. The lights are on. And for the first time, we can see where we are going. The puzzle is solving itself. This has been the story of AlphaFold 3.